So far we've had a look at the angle sum of a triangle and the angle sum of a quadrilateral. What we're going to have a look at is what if we've got different shapes like a pentagon or a decagon. How do we find the angle sum of those? Well, we need to know what some different things are first. So, first of all, a polygon is a closed figure with many straight sides. Many? Well, could be as few as 3. So let's start off with a triangle. That's our most basic closed figure with straight sides. 3 straight sides. If we go to 4 straight sides, it's a quadrilateral. And remember, there's all different types, like a square and a parallelogram and a trapezium, etc. If it's got 5 sides, it's known as a pentagon. And it doesn't matter if one of the vertices seems to come back in on itself. It still has 1, 2, 3, 4, 5 sides. A shape with 6 sides is a hexagon. So let's continue that. If it's got 7 sides, a heptagon. 8 sides, an octagon. 9 sides is a nonagon. And 10 sides is a decagon. So, let's go back and have a look at the triangle. We already know that the angle sum of a triangle is 180 degrees. Well, we're going to use that fact to help us find the angle sum of all these different types of polygons. So 180 degrees for those 3 angles on the inside. For a quadrilateral, well, as I said, we're going to use the fact that that's 180 degrees for a triangle. So I'm going to start with one corner of the quadrilateral, and I'm going to draw in a diagonal to any of the corners that are not next to it. Obviously, I can't join it to that one next to it because it becomes a side. It's not a diagonal then. Similarly, I can't join it to that vertex or that corner because, again, that becomes a side, not a diagonal. So I can cut it up to there. Now, I only want to cut it into the smallest number of triangles possible. So I've cut it into 2. I could draw other diagonals and cut it up into lots more triangles, but then it becomes messy and not useful. So I start with one corner, join it to all the other vertices that are not next to it, and that shows me the smallest number of triangles that I can cut it into. Remember, each triangle has an angle sum of 180 degrees. So these 3 angles inside this triangle are 180, and the 3 angles inside this triangle are 180. Well, this angle and this angle are going to add together, and this angle and this angle are going to add together. So 2 lots of 180 is going to give us a quadrilateral with an angle sum of 360 degrees. Now, we already knew that from our previous work, but this is an easy way to explain why. Well, let's extend that and go on to a pentagon. Remember, pentagon has 5 sides. So, start off with one vertex, and I join it to that vertex, it's not next to it, and then I'll again start from there and join it to another vertex that's not next to it. As you can see, I have 3 triangles, and I've already found the angle sum of one of them. The next one is also 180, and the third one also 180 degrees. So now I have 3 lots of 180 degrees, which will tell me the angle sum of that pentagon, which ends up being 540 degrees. So let's go to a hexagon. A hexagon has 6 sides. A little hint there is X in hexagon and X in 6. So start from one vertex, and I've started from this one here, and I've joined it to all the other vertices that are not next to it. So to there, and to there. And you can see I've now cut it up into 4 triangles, each one being 180 degrees. So we have 4 lots of 180 degrees, which ends up being an angle sum of 720 degrees for a hexagon. Now I could go and do this for the other shapes as well, the nonagon, the octagon, the 7-sided shape, the heptagon, the decagon, 10 sides. But instead of doing all of that, I'm going to do this a different way. I'm going to construct a table. So we already know 180 degrees, 360, 540, 720. So that will help us when I start to do the table. So I've got a table here. The shape, triangle, quadrilateral, pentagon, hexagon, heptagon, and so on. And you'll notice a funny one down the bottom here called an anagon. That's going to help me come up with a rule for finding the angle sum of any shape if I know the number of sides. So n for the number of sides. Triangle, three sides. Quadrilateral, 4. Pentagon, 5. Hexagon, 6. Heptagon, 7. Octagon, 8. Nonagon, 9. Decagon, 10. And my anagon, n sides. Now from our previous, a couple of minutes ago there, we had a look at that a triangle with 3 sides can be split up into one triangle. So one lot of 180 is 180. A quadrilateral into 2 triangles. Our pentagon into 3. Our hexagon into 4. So what you can see there seems to be a bit of a pattern in what's going on there. The number of sides and the number of triangles. They all seem to be 2 less. 3 minus 2 is 1. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So I can continue that pattern. 7 minus 2 is 5. 8 minus 2, 6. 9 minus 2, 7. 10 minus 2, 8. So my decagon I can make into 8 triangles. N. What happens when I minus 2 from that? Well, this becomes n minus 2. Now that I know the number of triangles, I just times it by 180, and that tells me the angle sum. So, a heptagon can be cut into 5 triangles. 5 lots of 180 is 900 degrees. So a heptagon has an angle sum of 900 degrees. My octagon, 6 lots of 180, and that's 1080 degrees. My nonagon, 7 triangles, 7 times 180, 1260 degrees. My decagon, 8 triangles, 8 times 180 degrees, and that ends up being 1440 degrees. So that leaves us with our anagon, okay, n minus 2, take the number of triangles and times it by 180 degrees. So I'm taking that number of triangles, but if I just times that by 180 as it is, I will only be multiplying that 2 by 180. So I need to make sure I put brackets around it because I'm multiplying all of that by 180 degrees. And that will tell me what the angle sum of that particular polygon is with whatever number of sides I put in there. So, as a summary, an angle sum of a polygon is the number of sides minus 2. That tells us the number of triangles, and then I times it by 180 degrees because that's the angle sum of each triangle. Remember, n is the number of sides of the particular shape we're looking at. So what we now need to do is have a look at a couple of examples. Let's find the angle sum of a polygon that has 12 sides. So, as I say to you over and over again, first of all, if there's a rule, write the rule. Once you write the rule, substitute in what you know. I know the number of sides is 12, so where I see the n, which is the number of sides, I replace it with 12. The next bit is just a calculator exercise. So get your calculator out, press that in your calculator, and you'll find the angle sum of a dodecagon, which has 12 sides, like a 50-cent piece, is 1800 degrees. Well, what about a shape with 20 sides? And you're probably asking, why would we want to have 20 sides? Well, maybe garden design. You might want a particular shape for your garden with 20 sides. Who knows? But let's have a look at how we work it out. Again, write the rule. Substitute in what I know. The number of sides is 20. Calculator exercise, work that out on your calculator. And the angle sum of a shape with 20 sides is 3,240 degrees. So let's have a look at one more example. What if I already know what the angle sum is? Well, what I can do is I can work backwards and work out how many sides that particular shape has. The way I start is really no different to what I've done before. Write the rule. So the angle sum of any polygon is the number of sides minus 2. Then I multiply that by the angle sum of a triangle, because that tells us the number of triangles, and that's the angle sum of each triangle. So, substitute in what I know. This time, I know that the angle sum tells us up here is 2,700 degrees, so I replace the angle sum with 2,700. Now, we've got to use our equation solving here. So what's the opposite of times? Well, it's divide. So to get rid of that times 180, I'm going to divide both sides by 180. When I do that, 2,700 divided by 180 is 15. And because I did the opposite of times 180, then that eliminated because they crossed out. So I've got my n minus 2. Well, I don't need brackets around that, so let's take those away because it's not being multiplied anymore by anything. And this should be something that you've seen before. Okay, so how do I get rid of that minus 2? I add 2 to both sides, and I find that n is 17. So the number of sides for this particular shape is 17 sides. So the key, use that rule, write it down, substitute in what you know, and rearrange it if you need to, or just a straight calculator exercise. So that's the angle sum of all these different polygons. Next time we'll have a look at what if the polygon is a regular polygon, because that makes things not much different, but you'll find something about the angles and sides.